Okay, let's move on to A2 physics के gravitation के past papers. Our first question is state the relationship between gravitational potential and gravitational field strength. Basically, we have to tell the relationship between phi and gravitational field strength. So if you have ever drawn a graph of, let's say, gravitational potential and radius, you might first of all know that it is entirely in the negative axis. Secondly, if I take the gradient of this graph, that is change in y over change in x. What is y here? Gravitational potential, change in phi over change in radius. What is the formula for phi? Minus capital G capital M divided by r. Divide by this r. What does this come out to be? Minus capital G capital M divided by r square. If you closely look at this thing, what is this equal to? Gravitational field strength ka formula. So the gradient of gravitational potential versus radius ka graph is equals to the negative of gravitational field strength. We will write it this. The gradient of gravitational potential versus gravitational potential and separation would be a better word, not radius. Gravitational potential and separation graph is the negative of gravitational field strength. Simple as that, nothing complicated in this one. Very easy question, very easy, 2 marks here. Gravitational field strength, I forgot to write field here, you can write it. A moon of mass m and radius r orbits a mass of planet 3m and radius 2r. ठीक है, एक moon है that has a mass of m, radius r, a planet that has a mass of 3m, radius 2r. At a particular time, the distance between their centers is d. Okay. At a particular time, the distance between the moon and the planet के center is d. Okay. Let's further move forward. A point P is a point along the line between the centers of the planet. ठीक है, एक point P है, that is a point along the centers of the planet. Okay. At a variable distance x from the center of planet. ठीक है, ये जो distance x है बेटा, this is the distance from the center of the planet, not from the moon. Okay. Let's study forward. The variation with x of the gravitational potential at P for points between the planet and the moon is shown. ठीक है, gravitational potential versus r का graph given है. This is basically the resultant phi का graph. जब आपने planet की gravitational potential और moon की gravitational potential की graph को add up किया तो you get this resultant phi का graph. Okay, up till now it is understandable. Explain why phi is negative throughout the entire range x is equals to 2r till x is equals to d minus r. यार ये पूरी रेंज में that is x is equals to 2r यहाँ पे होता है कि x is equals to 2r is somewhere here, that is from this point till this point, that is पूरा distance d. Why is this gravitational potential की value negative? So this is a very generic answer that you must write in your notes as well. ये 3 मार्क का आंसर है, मैं यहाँ पे लिखवा रहा हूँ. दिस विल सफाइस एवरी क्वेश्चन लाइक दिस कि ग्रेविटेशनल पोटेंशियल नेगेटिव क्यों होता है, ग्रेविटेशनल पोटेंशियल एनर्जी क्यों नेगेटिव होती है. You can write it down just as I write it. First point that you must mention here is that gravitational potential or phi is 0 at infinity. Phi की value जो है that is 0 at infinity. Okay sir, that's a good point. I got a 1 mark in there. How will I get the other 2 marks? Now the other 2 marks basically depend on your AS की थोड़ी सी work done की definition. Let's say this is the earth. Yeah, let's say this is any planet. Let's say this is any planet A. Where will the gravitational field be acting? The gravitational field or the gravitational force will always be acting inward. In other words, the gravitational force is always attractive. Okay. And let's suppose here you have an object. Let's say here you have an object. Let's say a stone. A stone is here. And you have to move it from this point towards infinity. You have to move this stone from point, let's say B, towards infinity. ठीक है. See what is happening. You have a planet A. Let's label this inside. Let's say this is Earth. ठीक है. Earth की gravitational field strength और gravitational forces are attractive. That is, they are acting towards the left side. You have a stone that you need to move from point B to infinity. Now, can you notice one thing here, that the force is acting towards the left hand side. The distance covered is towards the right hand side. So the work done will be negative because the force is towards the left, the distance covered is towards the right, just as we used to do with resistive forces. Okay, this is why gravitational potential की value is negative, because the gravitational forces are attractive, but the distance that you have to travel is on the right side from a specified point towards infinity. Basically, you have to escape infinity. That is the distance you have to travel towards the right side. Your gravitational forces are attractive towards the left. So when the forces and the distance are in opposite directions, your gravitational potential become negative. So how will you phrase your answer? First, second point, you will say that the gravitational forces are attractive. And what will be the third point here? Anyone with any answers here? What will be the third point here? In the third point, we will write, that is, work is done or work is given out to move the box or the point. What is here? We have a point. Okay. Work is done to move the point from a specified place to infinity. Okay, basically I hope you get your logics about gravitational potential की negative value now. ठीक है, let's move on to part 2. One of the features of the graph is that phi is negative throughout. यार एक feature of the graph क्या है कि phi is negative throughout. State two other features of figure 2.2. 2.2 पे क्या दो other features हैं? Can you see something? That the gravitational potential of the planet, let's say phi p, is more negative compared to the gravitational potential that I am drawing here for the moon. Yeah, here we have it. The gravitational potential for planet is more negative compared to the gravitational potential of moon. So I can write it here. Gravitational potential for planet is more negative than for moon. Is more negative compared to moon also serves right, and it is a greater word, compared to moon. Simple as that. Now let's come on to point 2. Okay, what will be the second point? If you can observe, the greatest gravitational potential की value is somewhere here. If you can notice, the greatest gravitational potential की value is somewhere here. If I take this value towards the top side, something like this. 1 second. Something like this. Okay, this is the greatest gravitational potential की value. Let me erase it. Let me eyeball it correctly. Yes, this is the greatest gravitational potential की value. Now you can do two things. You can just see it from your eyes as well, or you can just see it from graph. That at the greatest gravitational potential की value, which thing are you nearer to? Green वाला distance ज़्यादा है, yellow वाला distance ज़्यादा है? Obviously yellow वाला distance is greater. So at the greatest gravitational potential का point, you are nearer to the moon, because green wala distance is the moon. You can write this. At the greatest gravitational potential, greatest phi, I am just writing phi because gravitational potential would take up the entire space. The point is more closer to what? Closer to moon. Simple as that, nothing complicated. Chalo. Now let's see part 3. On figure 2.3, sketch the variation with x of the gravitational field strength at point P between x is equals to 2r and x is equals to d minus r. Basically, we have to draw the curve of resultant gravitational field strength. Very easy. First and foremost thing that you need to do and observe is that the planet, this wala planet will has its gravitational field strength towards the inward. So we can say the left hand side wale vectors are negative and right hand side wale vectors are positive. तो ये जो planet है उसकी हम gravitational field strength negative consider कर सकते हैं and the moon की gravitational field will also be inwards, but this is an arrow towards the right, so this will be positive. So these were the 2 marks out of 3 that you can get here easily. Let's say moon की somewhat here हो जाएगी and earth या planet की somewhat here at a negative value. ठीक है. Second या third up till now you have gotten 2 out of 3 here. I haven't drawn the curve, but I will draw it. But you have basically covered 2 basic points here. What was the third point for? Just look at it. At the maximum gravitational potential की value, your gradient. If I draw a tangent here, somewhere here, it will be giving a gradient of 0. And if this is giving a gradient of the 0, this means the gravitational field strength here is 0. Can I mark this 0 gravitational field strength by just 1 second? I will have to eyeball it. No, I can't eyeball it because it is on the other page. I will have to count the number of boxes. This is one large box and half box here and half box here. Okay. Basically from D minus R, we are from D minus R की marking, the gravitational field strength 0 का point कहाँ पे? Half box, one box and another half box away. Chalo. Let's move on to the graph again. This is the half box, this is one box, this is the half box again. So this is the point where the gravitational field strength will be 0. Now how will I draw the graph? Something like this. This is how you will draw this graph. You will get a 3 on 3. What were the 3 marks on? First was marking a null point here. Second was marking a negative gravitational field strength here. Third was marking a positive gravitational field strength here. Simple as that. I have the marking scheme attached so you can check it once you have answered the complete question. The earth may be assumed to be an isolated uniform sphere with a mass of this. ठीक है, earth का mass आ गया. A satellite of mass this. We have the satellite का mass as well. The period is this. Okay, we have the time period as well. Okay. Define gravitational field strength. What is gravitational field strength? Gravitational field strength is basically force per unit mass. Simple as that. Calculate the radius of the orbit of the satellite. Okay, just for a minute, think what is happening. Just for a minute, drop your calculations की hat and just for a minute think what is happening. Let's say this is earth beta, this is the satellite. ठीक है, this is the satellite, this is the earth. Satellite is orbiting around the earth. What do you think will be the force between the earth and the satellite? The force of gravitation, somewhat like this, Fg. What will be the force away from the satellite? The centripetal force Fc. Can I say at this point this gravitation की force is equals to the centripetal की force? Yes. What is the force of gravitation का formula? Capital G, capital M, small m divided by r square. What is the centripetal force का formula? mrw square. Right off the bat you can see one thing, कि m and m will get cancelled out, and also this is capital R as well, this is also capital R. ठीक है. Now what you can do, you can isolate R की values. Capital G, capital M divided by w square is equals to R cube. Now you will say, sir, I have capital G, I have capital M, that is the mass of earth, but I don't have W. Focus closely, you have W as well. What can W be written as? 2 pi divided by t. Do you have the time period? Yes. So let's place in all the values. G की वैल्यू क्या होती है? 6.67 into 10 raised to the power minus 11. What is the mass of Earth? 6 into 10 raised to the power 24. What is W की वैल्यू? 2 pi divided by time period क्या है? 94 into 60 whole square. And you take a cube root on this entire equation to get the radius. Let me minimize the diagram so I can write the answer clearly. Literally there are 3 marks for this simple question. Okay? So let me put this in the calculator. 6.67 into 10 raised to the power minus 11 into 6 into 10 raised to the power 24. Okay. And we divide this answer by 2 pi divided by 94 into 60, and let's put a square की value here and take a cube root of this. So this is a big calculation. I am unsure whether I will get the answer correct or not because I am bad at that. This 6.86 into 10 raised to the power 6 meters. This is your radius answer. Let's check in the marking scheme as well so that I have some calm. Yes, correct. Now I am calm. Chalo. Let's see option C. Rockets on the satellite are fired so that the satellite enters a different circular orbit that has a period of 150 minutes. Okay. Now basically you have a different circular orbit. This is the Earth again. Let's say, let me mark the Earth again with black to maintain continuity. Let's say this is Earth, this is the orbit again, and your satellite is moving around the Earth. Okay. The change in the mass of the satellite may be assumed to be negligible. हमें new orbit का radius दिखाना है, that is equals to this. So again beta, what we will do? We will say that the centripetal force away is equals to the gravitational force towards. Simple as that. Let's equate both these values. Gravitational force is equals to centripetal force. Gravitational force का क्या formula है? Capital G, capital M, small m divided by R square. What is centripetal force का formula? mR W square. What will happen? M and M will get cancelled out. R square और R multiply होके क्या हो जाएगा? R cube. Simple as that. Capital G, capital M divided by, this time your W is different. W is 2 pi divided by, what is the time this time? 150 into 60. Time has changed into 150 minutes. This is the only difference here. 2 pi divided by 150 into 60 ka whole square, and under root this value you will get your R. Chalo, I have the calculations already done here because, one second, oh, I haven't done this calculation. Let me grab the G and M key values from above. 6.67 into 10 raised to the power minus 11 multiplied by 6 into 10 raised to the power 24. Okay, then in the brackets here I will have 2 pi divided by, what is the time period this time? 150 minutes. 150 into 60 ka whole square. Okay, take an under cube of this one. This comes out to be, 9.36 into 10 raised to the power 6. Okay. Radius comes out to be, the new radius basically comes out to be 9.36 into 10 raised to the power of 6 meters. State with the reason why the gravitational potential energy of the satellite increases or decreases. Dekho, as you are going away from the planet, always remember, let's say, let me make the diagram here. You are going away from the planet. ठीक है, आपका radius बढ़ रहा है. Initially it was 6.86, now it is 9.36. Basically, let's say this is Earth and satellite initially यहाँ पे थी point A पे, अब point B पे है. Whenever you are going away from the planet or away from the Earth, remember your gravitational potential energy increases. Your gravitational potential energy increases. Simple as that. Remember this rule. And vice versa. If you are coming towards the planet, your gravitational potential energy will decrease. Determine the magnitude of the change in gravitational potential energy. Very easy. You have to determine the change in gravitational potential energy. How do you do that? Mass multiplied by change in gravitational potential. What is the mass of the satellite? Can anyone tell me that? What is the mass of the satellite? 1200 kg. चलो 1200 kg. अब चेंज इन फाई किस तरह निकालेंगे बेटा? चेंज इन फाई निकालने के लिए यू विल बेसिकली डू फाई एट द फाइनल पॉइंट, फाई एट बी माइनस फाई एट ए. चलो ऑलवेज रिमेंबर फाई का फॉर्मूला क्या है. ठीक है, फाई का फॉर्मूला क्या है? फाई का फॉर्मूला इज माइनस कैपिटल जी कैपिटल एम डिवाइडेड बाय आर. Okay, so first of all, minus capital G, capital M. What will be the R at the final position? You have just calculated 9.36 into 10 raised to the power 6 minus whole minus capital G, capital M. What is the R now? The R now is, initial R is 6.86 into 10 raised to the power 6. 6.86 into 10 raised to the power 6. Now take a whole bracket. बेसिकली हमने क्या किया है, पोजीशन ए पे आर क्या था 6.86, दिस इज द इनिशियल पोजीशन ए वाली. बी पे आर क्या था 9.36, दैट इज द फाइनल आर. वी जस्ट प्लेस डिफरेंट आर्स फॉर द डिफरेंट ग्रेविटेशनल पोटेंशियल. नाउ लेट्स सिंप्लीफाई इट फर्दर. 1200 और जी एम बी बाहर कॉमन ले सकते हो, मल्टीप्लाइड बाय 6.67 into 10 raised to the power minus 11 multiplied by what is the mass of the earth, 6 into 10 raised to the power 24, and take a whole bracket here. Minus minus क्या हो जाएगा, plus 1 divided by 6.86 into 10 raised to the power 6 minus 1 upon 9.36 into 10 raised to the power 6. Let me calculate this. ठीक है, 1200 into 6.67 into 10 raised to the power minus 11, okay, multiplied by 6 into 10 raised to the power 24, okay, multiplied by bracket 1 divided by 6.86 into 10 raised to the power 6, okay. Now further minus 1 upon 9.36 into 10 raised to the power of 6. What will be the answer? What will be the answer here? 1.869 into 10 raised to the power 10. If I take it till 3 significant figures पे अगर मैं ऐसे कर दूँ तो it will be 1.87 into 10 raised to the power 10. And if this is still 3 significant figures, and if I want to do it till 2 significant figures, it will be 1.9. ठीक है, it depends on what you have to answer. Yes, here you can see our answer is correct. Alhamdulillah, we are going good. This was a calculation heavy question, so getting these questions right makes me happy. ठीक है, state Newton's law of gravitation. What does Newton's law of gravitation states? 2 मार्क का सवाल है. You must state 2 points. What is the first point? That the force of attraction between two planets is directly proportional to the product of masses. Second point is that this force of attraction is inversely proportional to the separation between them, r square. Planets have been observed orbiting a star in another solar system. Measurements are made of the orbital radius and the time period of each of these planets. The variation with r cube of tu square is shown in figure 1.1. Okay, r cube और tu square की variation आपको ग्राफ में given है. Okay, perfect. The relationship between T and R is given by this equation, okay, where G is the gravitational potential and M is the mass of the star. Determine the mass M. Okay, we have to determine this mass M. If you closely look at this formula, अगर आप y axis पे, one second, let me break down this formula. T square is equals to 4 pi square capital G capital M R cube. If you break down this formula, T square की जगह you have plotted y, r cube की जगह you have plotted x. What is the gradient? Gradient is equals to 4 pi square divided by gm. Okay, so let's calculate the gradient first of all. Let's take the 2 for this point. Let's take this point, that is x की value में 0.2 into 10 raised to the power 34. Do not forget these prefixes, and slash time period is in air square. Okay, so 0.4 air square. Okay, what will be the second point that we will take? Let's take this point. This point is x may what? 1 and y may it is 2. Okay, the units remain same, I have told you. Now let's calculate the gradient. Let me write the points here as well, 1 and 2 and 0.2 and 0.4. First of all, let's calculate the gradient and then we will adjust it for the units. The gradient comes out to be y2, that is 0.4, minus y1 divided by x2, that is 0.2 minus x1. So 0.4 minus 2 divided by 0.8, this comes out to be minus 2. Okay. The gradient comes out to be plus 2 basically. Minus minus on the up and top side get cancelled out. What are the units for this? What are the units for this? Air square. Okay. And division में क्या आ रहा है? Okay. Now let's actually like convert it into the correct units. अभी ये किस units में? Air square divided by 10 raised to the power 34. Okay. So to make it in correct unit, first of all we have to convert air square. First of all तो air square को convert करना पड़ेगा in the correct unit. So 2 into 365 into 24 into 60 into 60. This is the amount of seconds in 1 year. And you will take a square of this divided by 10 raised to the power 34. Now we will have the actual answer. Let's do that. 2 into 365 into 24 into 3600. This was the actual trick in this question. Everything else was really easy. Now let me put a square here since it is air ka square, and divided by 10 raised to the power 34. What does this come out to be? 1.98 into 10 raised to the power minus 19. This is the actual gradient that we will be using. कन्वर्जन किस तरह की है बेटा? सिर्फ एयर स्क्वायर था तो एयर को सेकंड्स में कन्वर्ट किया, उसको स्क्वायर कर दिया. 10 raised to the power 34 था, डिवीजन में बस डिवाइड कर दिया. दिस इज योर ग्रेडियंट. नाउ लेट्स इक्वेट दिस कूल ग्रेडियंट to this value 1.999 ही कर देते हैं till 3 significant figures. 10 raised to the power minus 19 is equals to 4 pi square divided by capital G capital M. Okay, we have to calculate this M. Let's make this M the subject. Capital M is equals to 4 pi square divided by capital G into 1.99 into 10 raised to the power minus 19. What is G की value? G की value 4 pi square divided by 6.67 into 10 raised to the power minus 11 multiplied by 1.99 into 10 raised to the power minus 19. Okay. Now let's do the magic in the calculator. 6.67 into 10 raised to the power minus 11. Okay. And we will 4 pi square divided by this answer. The answer comes out to be round about, mass comes out to be round about 2.9 into 10 raised to the power 30 kgs. Okay? Basically it is 2.97. Yeah, you can do it 2.98 if you want to do it till 3 significant figures. So the correct answer will be 2.98 into 10 raised to the power 30 kg. So yeah. Now you can do it till 2 significant figures as well. 3.0 into 10 raised to the power 30. That looks more cleaner and I would also prefer that, but let me check the answer first of all. Yes, the answer is correct. 3.0 into 10 raised to the power 30, and the marking scheme will accept both the answers. So yeah. A rock of mass m is also in the orbit around the star in B. Okay. The radius of the orbit is r. Okay. Explain why the gravitational potential energy of the rock is negative. Now again you will copy paste this same answer which I told you to write in the first question. I think we did it in the first. Yes, this exact same answer will be copy pasted in the question below. This question gets asked very frequently. Every year this question appears in either one of the variants. So please go prepared with that. Show that the kinetic energy of the rock is given by this equation. Okay. So basically what is happening is you have a rock that is orbiting like this. This is the planet and the total separation between them is r. Okay. So can I say one thing, that the gravitational force is equals to the centripetal force? Yes, I can say that. The force of gravitation is equals to the centripetal force. What was the force of gravitation ka formula? Capital G, capital M, small m divided by r square. In this case we will be using a small r because in question we are given the small r. ठीक है, पिछले वाले क्वेश्चंस में कैपिटल r दिया था तो we just use capital R, और कोई रॉकेट साइंस नहीं है इसमें. mv square divided by r. We cut a small m with a small m. Okay, and what else can we do here? Okay, this r and r will get cancelled out. Velocity comes out to be what? Under root capital G m r. Now, do you guys remember the formula for kinetic energy? 1 upon 2 mv square. Do I have the velocity? Yes. Can I square it? 1 upon 2 into under root capital G capital M r. Square it. This square and under root will get cancelled out. Answer comes out to be 1 upon 2 capital G capital M small m. This is what we had to show. Simple as that. Use this expression in C2 to derive an expression for the total energy of the rock. Okay, what will the total energy of the rock be equal to? Total energy of the rock will be equal to gravitational potential energy plus kinetic energy. Do I know the formula for gravitational potential energy? Yes, I know it. Minus capital G capital M divided by R, plus what is the formula for kinetic energy? Capital G capital M small m divided by 2R. If I take an LCM, the answer comes out to be minus capital G capital M small m divided by 2R. This is your total energy ka formula. Let's move further. Yes, we have calculated it correctly. Gravitational potential at a point. This is further easier. I have already taught you what is gravitational potential. Let's further move on to this. An isolated sphere of radius r may be assumed to have its mass m concentrated at its center. See, one more thing that I want to clear here is that these videos ka purpose is to do the most difficult questions. Things like these you can take it from the notes or define it yourself. They are really easy. Let's move on to question B. The magnitude of the gravitational potential at the surface of the sphere is phi. Okay. On figure 1.1, show the variation of the gravitational potential with the distance d from the center of the sphere for the values of d. Okay. We have to show gravitational potential versus radius ka graph. First and foremost thing which will carry a marks here is that your entire graph will be in this negative axis. Nothing will be in the positive axis, because gravitational potential ka pura graph negative axis mein hota hai. Okay. Secondly, the graph will be an inverse graph. At a position of r, you will have a negative phi. At a position of 2r, your phi will decrease by half, minus 0.5. At a position of 3r, let me find minus 0.3r. 1, 2, 3, 4, 5, 6. Okay. So basically, two boxes here represent 0.1. So the 0.3 wala box will be 1, 2, 3, 4, 5, 6, somewhere here. Yeah, somewhere here. Okay. And when you are at 4r, you will be at 0.25. So 1, 2, 3, 4, 5, somewhere here. So the curve will look like this. Okay. Apologies for my drawing, but the only thing that I have considered here, I will also write it in equation as well, that when the r became 2r, my phi will decrease from negative to minus 0.55. Okay. When my r increased to 3r, my phi will go from negative phi to minus 0.35. When my r increased to 4r, my phi will decrease to negative of 0.255. Simple as that. Okay. The sphere in B the sphere in B is a planet of radius this. Okay, you are given the radius and a mass of radius this. See, the radius and mass are of the planet Earth. So this is quite evident. A rock of mass 3.4 into 10 raised to the power 3 kg moves directly towards the planet. It is a distance from the center of the planet changes from 4r to 3r. Okay. Basically what is happening? Just look at it. Let me draw the diagram. Let's say this is a planet. We know that this is Earth. Why? Because we are given the radius and the mass same as Earth. Okay. There is a rock that is initially, let's say this is the center of the Earth, planet, that was initially a distance of 4r away, and now it's a distance of, let's say, 3r away. This was the initial position and this was the final position. Okay, let's see what we have to calculate. Nothing has been told to us right now. Calculate the change in gravitational potential energy. As expected, we have to calculate the change in gravitational potential energy. Okay, so let's start. Change in gravitational potential energy, I have just told you it is equals to mass into change in gravitational potential. ठीक है, यही चीज़ करते थे ना gravitational potential energy का change निकालने के लिए. What did we used to do? Change in gravitational potential multiplied by mass. Rock का mass क्या है? 3.4 into 10 raised to the power 3 kg. 3.4 into 10 raised to the power 3 kg. Change in gravitational potential किस तरह निकलेगा? फाइनल पोजीशन पे ग्रेविटेशनल पोटेंशियल निकालो, माइनस कैपिटल जी कैपिटल एम. रेडियस क्या है फाइनल पोजीशन पे? 3 इंटू व्हाट इज द आर? 6.4 इंटू 10 रेज़ टू द पावर 6 माइनस व्हाट इज द इनिशियल पोजीशन? माइनस कैपिटल जी कैपिटल एम. इनिशियल पोजीशन पे रेडियस क्या है? 4 इंटू 6.4 इंटू 10 रेज़ टू द पावर 6. सिंपल एज दैट. ओके, now 3.4 into 10 raised to the power 3, take g and m common, 6.67 into 10 raised to the power minus 11 multiplied by mass of the planet, that is equals to 6 into 10 raised to the power 24. Okay, and this minus will become plus 1 upon 4 into, okay, so this is getting too much of the calculation. Let me make it towards this side. Okay, 1 upon 4 into 6.4 into 10 raised to the power 6 minus 1 upon 3 into 6.4 into 10 raised to the power 6. Let's calculate the answer. Let's see what do we get as our answer. I think we will get a negative answer. Let's see. 3.4 into 10 raised to the power 3 multiplied by 6.67 into 10 raised to the power minus 11 multiplied by 6 into 10 raised to the power 24. Okay, up till now it is correct. Then what I can do is 6.4 into 10 raised to the power of 6. Okay, multiply this by 1 upon 4 minus 1 upon 3. This comes out to be what? Minus में answer आ रहा है. I was correct. Minus 1. Let's keep it till two significant figures. 1.8 into 10 raised to the power 8 joules. Now let me see what we have to state here. We have to state the change. जब भी change देना होता है, you ignore the minus plus का sign. So you will just say 1.8 into 10 raised to the power 10 joules. Explain whether the rock की speed increases, decreases or stays the same. Basically, there is a loss in gravitational potential energy. This will get converted into what? Gain in kinetic energy. And if there is gain in kinetic energy, velocity will increase. Simple tareen answer, nothing complicated. Let's move on to the next question. I hope I have calculated this correctly. Yes, I have calculated this correctly. Let's move on to this one. 2 point masses are isolated in space and are separated by a distance x. Okay. State an expression relating the gravitational force between the two masses m and small m and state the name of any other symbols used. Okay. Gravitational force किसके equal होती है? Capital G capital M small m divided by x square, that is the separation between them. Is there any symbol that I have used other than the provided in the question? Yes, this capital G. Capital G किसके equal है? Gravitational, universal gravitational constant is the correct word, I guess. Universal gravitational constant. Simple as that. Nothing complicated, nothing rocket science here. Now, let's move on to part B. A spacecraft is to be put into a circular orbit about a spherical planet. Okay, the planet may be considered to be isolated in a sphere. The mass of the planet may be assumed to be concentrated at its center. Okay, that is 7.5 into 10 raised to the power 23 kg. The radius of the planet is also given, that is 3.4 into 10 raised to the power 6 meters. The spacecraft is to orbit at a height of this, okay, above the surface. At this altitude there is no atmosphere. Show that the speed of the aircraft in its orbit is this. Okay, we have to show that the speed of the aircraft at this point, that is 2.4 into 10 raised to the power 5 meters above the planet is this. Okay, so what we will do, if we just look below, we are actually given the diagram, but I will suppose that I have not seen it. I have not seen the diagram and I am in exam ki tension. So what will I do here? Let's say this is the orbit of the spacecraft. Let's say this is the planet. Okay, let me draw the planet correctly. 1 second. Let me make it a bit smaller. Let's say this is the planet and the radius of the planet is given to you. Yes, it is given to you, that is, let's say it is 3.4. okay, that is given. Let me write it with a thin pencil here. 3.4 into 10 raised to the power 6 meter is the radius of the planet. Your spacecraft is a further distance of what? It is a further height of 2.4 into 10 raised to the power 5 meters from the surface. So the total distance is this yellow highlighted area. The total distance or the total separation is this yellow highlighted area. What do you have to calculate? You have to calculate the speed. What will I do? I will say that at this point the gravitational force and the centripetal force of the aircraft are equal. Okay, this is the gravitational force, this is the centripetal. Whereas I can mark the gravitational force on this line only. Gravitational force. Chalo. Gravitational force is equals to centripetal force. Gravitational force का क्या formula होता है? Capital G, capital M, small m divided by what? Divided by R square. That is the separation का square. Okay, has the examiner placed a different symbol here? चलो x का symbol use किया तो हम x use कर लेते हैं, r को skip कर देते हैं. और सेंट्रीपिटल फोर्स का क्या फॉर्मूला होगा? सेंट्रीपिटल फोर्स का फॉर्मूला विल बी mv square divided by x. And this will get cancelled out. M and this will get cancelled out. What will be the velocity? The velocity will be capital G, that is 6.67 10 raised to the power minus 11. What will be the mass of Earth? Mass of Earth is 7.5 into, not mass of Earth, the mass of planet. Okay, divided by what is the separation? Now this is an important point. That's why I have drawn this diagram. The separation is the sum of these two values, the radius and the height. So let's add them up. 3.4 into 10 raised to the power 6 plus 2.4 into 10 raised to the power 5 and take a under root of this velocity. Let me calculate it. The velocity comes out to be 3.7 into 10 raised to the power 3 ms minus 1, just as stated in the question. Let me erase this a bit so that you can see this is 3.7 ms minus 1. 3.7 10 raised to the power 3 ms minus 1. This is the velocity that we needed to calculate, and here we have it. Simple as that. So this means if I just look at the diagram here, this means at point A, that is at the same height, अगर आप यहाँ पे 3.4 into 10 raised to the power 6 plus 2.4 into 10 raised to the power 5 plus करोगे, you will be at the same height. The velocity at this height is 3.7 into 10 raised to the power 3. Okay, let's see further. planet ka mass is the same. Okay, the spacecraft enters the orbit at point A, okay, with a speed of this, okay, at point B a distance of 5 into 10 raised to the power 7 meters. सही है, point B इतना distance away है from the center of the planet. It has a speed of this. Point B पे speed क्या है बेटा? Point B पे speed is 4.1 into 10 raised to the power 3 ms minus 1. Okay. The mass of the spacecraft is this. Okay, this is the small m. If we need it, we will use it. ठीक है. For the aircraft moving from B to A, this is a journey from B to A. Okay. Show that the change in gravitational potential of the spacecraft is this. Okay. First of all, we have to calculate the gravitational potential energy का change. Change in gravitational potential energy कितनी दफ़ा कर चुके हैं? It is mass into change in gravitational potential. What is the mass of the spacecraft? 650. What is the change in gravitational potential? What is the final position, beta? Final position is the position at A. So phi at A minus phi at B. What will be the phi at A? Let's calculate that. 650 into minus capital G, capital M. What is the radius at A? Can you see? 3.64 into 10 raised to the power 6. 3.64 into 10 raised to the power 6 minus capital G, capital M. What is the radius at B? 5 into 10 raised to the power 7. Chalo, let's put that. Now let's see what will be the answer. Let's first of all take GM common. 650. I think again we will have a negative answer. Why can I tell that we will have a negative answer, we will have a positive answer before even calculating? Because see, the initial distance between the planet and the point was 5 into 10 raised to the power 7. The final distance has become less. What have I told you? Whenever we will move toward the planet, our gravitational potential energy will decrease. So let's see. I am hoping for a negative answer here. G is 6.67 into 10 raised to the power minus 11. What is the mass of the planet? The mass of the planet was also given. Yeah, here we have it. 7.5 into 10 raised to the power 23. And yeah, that's it. Minus minus becomes positive. 1 upon 5 into 10 raised to the power 7 minus 1 upon 3.64 into 10 raised to the power 6. Okay, let's see what will happen. 650. My expectations are that we will get a negative answer because we are moving towards the planet, and when we are moving towards the planet, we always get a negative value of gravitational potential energy. Or you can say whenever we are moving towards the planet, there is a loss in gravitational potential energy multiplied by, let me calculate it, 1 divided by 5 into 10 raised to the power 7 minus 1 divided by 3.64 into 10 raised to the power of 6. What will be the answer? Yes, the answer comes out to be negative. Very likely. The change in gravitational potential energy is minus 8.28 10 raised to the power 9. Let's write it till two significant figures. Minus 8.3 into 10 raised to the power 9 joules. Also, whenever we are writing change, we will ignore the negative ka sign. So we will just write 8.3 into 10 raised to the power 9 joules. Simple as that. Let me verify the answer. Yes, correct. By considering the changes in gravitational potential energy and kinetic energy of the spacecraft, determine whether the total energy of the spacecraft increases, decreases in moving from point B to A. ठीक है, point B to A जब जा रहे हो तो velocity क्या कर रही है? Decrease. तो what would have happened to kinetic energy? Decrease. Gravitational potential energy अभी देख लिया कि negative आ रही थी, means it is decreasing as you are going from point B to A. So what will you write here? As you go from point B to A, gravitational potential decreases, kinetic energy decreases, hence total energy decrease. How do I know that kinetic energy is decreasing? Because आप B पे velocity देखो क्या है? 4.1 into 10 raised to the power 3. आप A पे velocity देखो क्या है? 3.7 into 10 raised to the power 3. So the velocity is decreasing, the kinetic energy will decrease. Simple as that. I have attached the marking scheme. Let's move on to our last and final question. Define gravitational potential at a point. You will be easily be able to do this through the notes, through the videos of the A2 playlist. A rocket is launched from the surface of a planet and moves along a radial path as shown in figure 1.1. Okay. The mass may be considered to be an isolated sphere of radius r, okay, with all of its mass m concentrated at its center, okay. Point A is a distance r from the center of the mass, okay. Point B is a distance of 4r from the center of the mass, okay. Show that the difference in gravitational potential between A and B is given by this expression, okay. We have to show that A और B के बीच में जो gravitational potential का difference है, gravitational potential का difference, that is given by this expression, okay. Let's first of all calculate the gravitational potential at A. What is the capital G, capital M minus and what is the total distance 2r. ठीक है, A पे total distance क्या है बेटा 2r, because we always take the distance from the center of the mass. What is the gravitational potential at B? Minus capital G, capital M. What is the total distance? This blue highlighted 4r plus this r. So the total distance will become 5r. Okay, now let's calculate the difference in gravitational potential. We can say gravitational potential of B minus gravitational potential of A. What is the gravitational potential of B? Minus capital G, capital M divided by 5r. Okay, minus capital G, capital M divided by 2r, which is the gravitational potential of A. Capital G, capital M divided by 2r plus, oh sorry, minus. This negative will get plus, so capital G, capital M divided by 2r is plus, minus capital G, capital M divided by 5r. Let's take the LCM. This will get multiplied by 2, this will get multiplied by 5. What will happen? 5 capital G, capital M minus 2 capital G, capital M divided by 10r. What does the answer come out to be? 3 capital G, capital M divided by 10r. Is the answer matching to our initial equation? Yes, so we are correct. Let's further move ahead. A rocket is switched off at point A. ठीक है, एक rocket है जो कि point A पे switch off कर दिया गया है. ठीक है, during the journey from A to B, the rocket has a constant mass of this and its kinetic energy changes from this to this. मतलब kinetic energy का क्या हो रहा है? Loss हो रहा है. Okay. For the planet, the product Gm is this. It may be assumed that the resistive force due to motion are negligible. Use your answer in B to calculate the distance from A to B. Okay, बेटा इसमें सिर्फ सिंपल सी क्या चीज़ करनी है, मुझे पता नहीं एग्जामिनर ने सवाल इतना आसान क्यों दिया है. As you are moving away from the planet, क्या हो रहा है? A से B जाओगे तो क्या होगा? Gravitational potential energy का increase और kinetic energy का loss. Okay, I understand that. चलो. So what will I write? Loss in kinetic energy is equals to gain in gravitational potential energy. Okay. Now, how will I calculate the loss in kinetic energy? Final kinetic energy. First of all, I will put a negative sign. Whenever you have a loss का term in energy, you put a negative sign here. Okay, so first of all, let's put the final kinetic energy, that is 0.88 terajoules है, तो basically 10 raised to the power 12 होगा. So I will put that in the whole bracket 1.7 और whole bracket में मैंने 10 raised to the power 12 कर दिया. Simple as that, because terajoules was written. अब gain in gravitational potential energy बेटा किस तरह निकलेगा? Mass of the rocket, that is 4.7 into 10 raised to the power 4 multiplied by what? Multiplied by the value that you have calculated. कौन सी वैल्यू निकाली है? कैपिटल 3. बेसिकली अगर यहाँ पे देखो तो आपकी फाइनल ग्रेविटेशनल पोटेंशियल क्या है? फाई बी. इनिशियल ग्रेविटेशनल पोटेंशियल क्या है? फाई ए. So we have already calculated the change in gravitational potential. We have just put here. We will just put it here. क्या आ रही थी वैल्यू? 3 capital G capital M divided by what? 10R. I hope so. Yes, 10R. ठीक है. अब हमें कैपिटल जी एम की भी वैल्यू गिवन है. इतना आसान कोई सवाल दे सकता है? दिस इज 4 into 10 raised to the power 14. Let's erase this and write 4 into 10 raised to the power 14. 4 into 10 raised to the power of 14. Simple as that. Can you see there is only one unknown variable in this equation? Yes, I can see that. Okay, chalo, let's rearrange this equation a little. First of all, 0.88 minus 1.7, this gives me a value of what? 0.82. Okay. Now, what will I do? 10R is equals to 4.7 into 10 raised to the power 4 into 12 into 10 raised to the power 14 divided by what? divided by 0.82 into 10 raised to the power 12. Also, I will bring this 10 towards the downside, so I don't have to do an extra calculation step. Multiplied by 10. I just brought the 10 to the downside. Let's put all these values. 4.7 into 10 raised to the power of 4. Okay, multiplied by 12 into 10 raised to the power of 14. Okay, further divided by 0.82 into 10 raised to the power of 12. Further multiplied by 10. What does the answer come out to be? 6.9 into 10 raised to the power 6. Radius ka answer comes out to be 6.9 into 10 raised to the power 6 meters. Simple as that. Let's confirm it. Whether we are, no, we have to calculate the distance between A to B. Oh, we missed a very important step here. A to B तक का distance निकालना है. That is what? That is 3r. ये 3r है. हमने अभी सिर्फ r निकाला है. What we will do? We will multiply it by 3. I just realized what we were doing here. If r is this, 3r will be what? 3 into 6.9 into 10 raised to the power 6. Let's do that. One last step and then you guys are free. 2.0 into 10 raised to the power of 7. Oh, what am I writing? 2.0 into 10 raised to the power of 7 meters. Simple as that. Let's see whether our answer is correct. Very good. Our answer is correct. Okay. I hope this was clear to you guys and there were no other confusions. If you had any other questions, you can ask me in the comments below and I will clear it out. Thank you for watching.